Assalamualaikum warahmatullahi wabarakatuh. Hi guys. So for this week, you are going to do some experiment, which is experiment 8 about the amplitude modulation and also frequency modulation. Okay, now I will explain a little bit the theoretical part of the amplitude modulation, and after that I will continue with the frequency modulation in the next slide. Okay, for the amplitude modulation, before I proceed with the modulation here, I will explain a little bit about the communication system, okay, because this is something new for you all. Okay, you never learned about the communication system during your first and second semester. Okay, you will start to learn about the communication subject in your part 3. Okay, so I just give some introduction to the communication. Okay, so what is communication? It is actually the process of sending information. Okay, it's very simple. Okay, actually communication happens in our daily life. Okay, every day we communicate either with our friends, with the family, either using electronic device and so on. So that one is called the communication. Okay, so when we want to deliver some information to other people, okay, so there must be a source and also a destination. Okay, so this is the flow of information, and this one is the basic diagram of a communication system. Okay, so 3 elements which is important in the communication system. Okay, those 3 elements are the transmitter here. Okay, and this one is the communication channel or the medium. Okay, what medium you are going to transmit your information, and also the receiver. Okay, so these are the 3 elements which is very important in communication system. Okay, and the others is the message inputs, it's either the voice, data, pictures, and so on, and also the destination. Okay, where we want to deliver our information. Okay, but not to forget, in this communication channel or medium here, there must be a noise. Okay, so it's either the noise from the cable itself or the noise from the surrounding, attenuation, and so on. Okay. Okay, now we go to the modulation first. Okay, so what is actually modulation? Okay, before you go through the amplitude modulation, frequency modulation, and so on, you have to know what is actually modulation. Okay, modulation is the process of modifying or changing one or more properties of the carrier signal. Okay, carrier signal is something, a signal which is periodic waveform, which has higher frequency compared to the information signal. Okay, so carrier signal and information signal are two different signal. Okay, so you have to understand about carrier signal and information signal. Information signal, there are 3 names that you can use. It's either you can use information signal, or baseband signal, or modulating signal. These 3 names are same, give the same meaning. Okay, which is information signal, the signal that we want to transmit. Okay, the carrier signal is something that helps the information to be transmitted. Okay, so I give you one analogy here. For example, you are standing in a building A, okay, and you want to send a letter to your friend which is at building B. Okay, these 2 buildings is about 5 meters away. Okay, so you want to send a letter, a piece of paper to your friend at building B. But how you want to make sure that the letter will be reached by your friend at building B? I'm sure that if you just throw the letter, it won't be reached to your friends, which is 5 meters away, because the letter is very light, right? It is very light, so there are big possibility that the letter will just go halfway to your friends. So how you want to make sure that the letter is can definitely be reached by your friend? Okay, so you need something. Okay, you need help from others to make sure that the letter can be sent to your friends. It's either you need help from the bird, like before this, all this, or you just can wrap the letters with something that is much heavier, for example, the stone and so on. Okay, what I'm trying to say here is that it's either you are using a bird, or you are using the stone, or something that is heavier. That one is actually the carrier. Okay, and the letter is the information signal, and the birds or the stone and so on, that one is the carrier. Okay, that one is the analogy that it's easier for you to understand what is carrier, what is the information signal. Okay, so modulation is actually something that we want to change. Okay, modify. You want to change or modify our carrier signal. Okay, so the carrier signal can be changed. It's either the amplitude of the carrier signal, or the frequency of the carrier signal, or the phase. Okay, so this is where amplitude modulation, frequency modulation, and phase modulation come. Okay, so this is the basic of the modulation. Okay, so as I told you before this, the carrier usually a sine wave having a higher frequency than the modulating signal. Okay, so it must have a very higher frequency. Okay, because you want to transmit the information signal. Because when the frequency is much higher, so it can go further away. Okay, it can go further away. It can transmit the modulating signal to the receiver. Okay, so a modulator is a circuit which performs modulation in a transmitter. Okay, so the process of modulation will be occurred in the modulator. So the modulator is located in this transmitter here. Okay, so this is the basic block diagram of the communication system that I've showed you before this. So the modulator consists in this transmitter. Okay, so this is the channel. The medium is either you're using wire, or wireless. Okay, so this is the medium. And this is the receiver. Okay, what happened in the receiver is that the reverse process of the modulation, which is called demodulation. Okay, so demodulation is the reverse process of modulation. So it will extract the original baseband information signal and transmit the message. Okay, once we do some modulation in the transmitter here, the signal will be changed. Okay, so it is called modulated signal. Okay, in order to extract back the original information signal, so the demodulation process must be occurred here inside the receiver. Okay, so this is called the demodulation. Okay, so we go to the amplitude modulation. Okay, what is amplitude modulation? It is the process of varying the amplitude of the radio frequency carrier wave, okay, by the amplitude variations of a modulating signal or information signal, which means we will modify the amplitude of the carrier wave, okay, with respect to the amplitude of the modulating signal. Okay, you can see here from this block diagram here. So in the AM modulator is located in the transmitter. Okay, two signals will be the input of the AM modulator. Okay, the first one is the modulating signal or our information signal, and the second one is the carrier signal. Okay, these two signals will be the input of the AM modulator, and the output is the modulated signal, which means the signal has been modified. Okay, it is called modulated signal, and this is AM signal, amplitude modulated signal. Okay, so instantaneous value of the carrier amplitude changes in accordance with the amplitude variation. Okay, here are some application of AM. Okay, for example, radio broadcasting, TV pictures, facsimile transmission, and so on. And the range of frequency for AM is normally 500 till 1600 kilohertz. Okay, around this frequency, and the bandwidth is 10 kilohertz. Okay. So we can see here from this diagram here. So this is the modulating signal or our information signal. Okay, so this is the signal that we want to transmit to the receiver. Okay, it can be in form of data, image, and so on. So this is the modulating signal. Okay, this is the carrier signal. Okay, carrier signal which will help this information signal to be transmitted to the receiver. Okay, so you can see here it is close to each other, which means it has very high frequency, okay, compared to modulating signal. Okay, so these are the modulated signal, okay, as a result of a combination of the information signal and also carrier signal. When it goes into this AM modulator, okay, so the output will be the modulated signal, and this is the picture or the diagram of the modulated signal, the graph of the modulated signal. Okay, so I won't go through into detail about this. Okay, you will learn this in your next semester. Okay, I just give you the general information about the AM. Okay, so we have an equation here, okay, which is the ratio of the amplitude modulating signal to the amplitude of the carrier signal. It is called modulation index. Okay, so for each of the signal here, so this is where the amplitude of the modulating signal, okay, which is the peak of the graph, and this one is the amplitude of the carrier signal, which is the peak of this carrier signal graph. So the ratio between the BM and VC is called the modulation index. Okay. So these are the modulated signal. Okay, so same like this graph here. Okay, so this is the AM modulated signal. Okay, from this graph also, we can obtain a few parameters. Okay, for example, at the peak here, okay, so this is called the V maximum. And this one here, at the lowest part here, this is called the V minimum. Okay, so V maximum is actually the addition of the carrier, amplitude of the carrier, and also the amplitude of the modulating signal, which is Vc plus Vm. Okay, and then Vmin is actually the subtraction of the carrier amplitude to the modulating amplitude. Okay, so from this Vmax and Vmin, we can also determine the modulation index. Okay, so before this is the equation that we can use to obtain the modulation index. But if we have the value for Vmax and Vmin, we can also calculate the modulation index from this equation here. Okay, and then modulation index, sometimes we want to give in terms of the percentage, so you can just times with 100%. Okay, so this is the circuit for AM modulator. Okay, so as I told you before, this AM modulator is located in the transmitter. Okay, what electronics device is inside this? What electronics components is inside this AM modulator is that it has this resistive mixing network, which is consists of the resistor here. Okay, so this is where the modulating signal will go through, and this is the carrier signal, and it will mix up together and go to this R3, and it has this diode rectifier. Okay, so something happened here, which is it tried to give the signal only the positive signal. Okay, forward bias here, and then this one is the LC tune circuit. Okay, so this is for the tuning. All right. So the last one is AM demodulator. So AM demodulator is actually the reverse process, which means this one here, the input is the AM signal. Okay, if the AM modulator here, the input will be the original signal or the information signal, and also the carrier. But for AM demodulator, the input will be the AM signal, because you want to convert back the modulated signal, which is the AM signal, to the original information signal. So this is the AM demodulator. Okay, so it is a circuit that accepts a modulated signal and recovers or detects the original modulating information. Okay, so the circuit here consists of diode and also resistor and also capacitor here, and the output will be that we get here is the original information signal or demodulated signal. Okay, so this is the AM frequency spectrum. Okay, these are the results that we can observe from our AM modulated signal. Okay, so from AM frequency spectrum, you can see here there are a carrier frequency here, carrier frequency, which is FC, and it has two sidebands. Okay, AM signal that results in two sidebands and a carrier. Okay, so this is often called double sideband amplitude modulation. Okay, DSBAM. Okay, so there are also other AM signal result that can be produced. Okay, for example, single sideband and so on. Okay, but for this time, we just go through this double sideband amplitude modulation. Okay, double sideband means it has this lower sideband and also upper sideband. Okay, so for the lower sideband, the frequency that we can get here is just the frequency from the carrier minus with the frequency from the modulating signal, and for the upper sideband is that the addition of these two frequencies. Okay, and the amplitude here is just the M here is the modulation index times with the amplitude of the carrier signal over 2. Okay. Okay, so the difference between these two frequencies here, okay, we'll get the bandwidth. Okay, so B refer to the bandwidth. Okay, so which is the difference between upper sideband and lower sideband, or we can directly just calculate for the bandwidth. It just equal to 2 times with FM, which is FM is the frequency of the modulating signal. Okay, so that's all for the theoretical part for this amplitude modulation. Thank you.